While the titans of the Mesozoic era dominated the planet roughly 252 to 66 million years ago, a separate, ancient lineage of mammals was quietly thriving. Tiny, secretive, and barely a whisper in the fossil archives. Then, they seemingly disappeared into the void, presenting us with a baffling riddle. What was the ultimate fate of these creatures? Sediments stretching from the Jurassic through the Cretaceous tell us they were anything but irrelevant. Specimens like the Morganucodon and the varied clans of multituberculates prove that mammals of this era boasted sophisticated dental layouts, advanced jaw mechanics, and a surprising ability to inhabit different environments. They navigated the gloom of deep woodlands, emerging solely under the cover of darkness to evade the gaze of gargantuan hunters, unraveling the enigma of their existence and their eventual broad-scale extinction. Starts with the earliest scraps hidden deep within the bedrock. For a long time, our understanding of these dinosaur-age mammals was cobbled together from nothing more than isolated petrified teeth, the odd jaw fragment, or the rare, splintered bit of a cranium. Based on this scanty data, the scientific community settled on a theory that felt logical at the time. The assumption was that Mesozoic mammals were basic, diminutive beasts cowering in the footprint of massive reptiles. That changed in 2003, when excavators working in the ancient lakebeds of northern China unearthed a spectacularly intact skeleton entombed in fine silt that had settled in tranquil waters. Radioactive dating pinned the sediment's origin to the Middle Jurassic, around 164 million years back. But the real shock wasn't just how old it was the anatomy of the animal trapped inside. This specimen stretched at least 42.5 centimeters from nose to tail, and tipped the scales at roughly 800 grams, dwarfing the classic caricature of a dinosaur-era mammal. It sported a coat of fur, a hallmark of mammals, proving that internal body heat management was already well established. However, the true game-changers were found on its appendages and rear. Webbing connected its toes, and its tail was flattened out horizontally, resembling a paddle. This creature didn't fit neatly into any modern family tree. It was identified as a mammaliaform, a transitional stage on the evolutionary ladder sitting just outside the group of true mammals. Its discovery was absolute proof that as far back as the Jurassic, even with dinosaurs ruling the terra firma, ancestral mammals were already conquering complex habitats, including the water. Prior to this find, experts believed mammals didn't take to the water until much later, waiting another 100 million years for lineages closer to modern species to evolve. That single fossil from 2003 rewound the clock by more than 100 million years, completely upending our theories on the pace and variety of early mammalian development. If a mammaliaform had fur, webbed feet, and a swimming tail 164 million years ago, nature was experimenting with these designs shockingly early. In an ecosystem defined by cutthroat survival and immense pressure, tiny creatures in lush jungles, wetlands, or riverbanks are far less likely to fossilize than the massive beasts dying on arid plains. The burning question is, after the cataclysm that ended the Cretaceous, why did only a few genetic lines endure while so many evolutionary experiments were wiped out? The solution can be found in the events that transpired, in the aftermath, through a cascade of ecological shifts spanning tens of millions of years. For almost 100 years, the prevailing view of mammals during the dinosaur age depicted them as little more than shrews, creatures weighing mere ounces, skulking around in the dark, and barely scraping by, on a diet of bugs. Throughout the bulk of the 20th century, our knowledge of these Mesozoic beasts was limited to teeth and jaws. Since those are the most durable parts of the anatomy, they are essentially the only things that survive to become stone. On the flip side, fragile pieces like rib cages, slender vertebrae, and soft tissue almost never survive the ages. For the longest time, researchers were left playing detective with nothing but stray teeth to figure out how big these creatures were or how they lived. And the story those teeth told was simple. Most Mesozoic mammals were tiny, with many tipping the scales at just tens to a few hundred grams. Now, in today's wild, animals that small can still be fierce hunters, architects of their environment, or key players in keeping bug numbers down. But as the calendar flipped from the 20th to the 21st century, fresh evidence started piling up piece by piece across China, Mongolia, and North America. These regions hold fine-grained dirt and ancient landscapes that are perfect for locking small, delicate skeletons in time. Suddenly, the script flipped. We found cat-sized predators over 1 meter long, armed with jagged teeth and powerful legs, capable of taking down lizards, reptiles, and even baby dinosaurs. Then there were the climbers. with skeletons and claws proving they were master acrobats, grew in a high canopy where the lumbering giants below couldn't touch them. Meanwhile, others developed stout arms and heavy claws, built specifically for moving earth and living a life underground. But here is the real kicker. All these different survival strategies were happening at the exact same time. It proves that Mesozoic mammals weren't just waiting in the wings. They had already branched out, carving out their own distinct niches. Modern paleontology has moved way past guessing from bone shards. Today, it is about blending shape analysis, the physics of movement, microscopic bone scans, and real-world comparisons to animals alive right now. These deep dives revealed that many of these ancient mammals ran hot, burning energies quickly, regulating their own body heat, and showing a surprising amount of behavioral flexibility. Looking back, sure, a lot of them were pint-sized creatures of the night. But the night wasn't just empty darkness. It was a thriving arena with its own rules, where being massive didn't automatically make you the king. So, if these early mammals were already this varied and successful, why didn't they explode into the dominant forms we see today right then and there? To understand that, you have to look at the tangled web of the Jurassic, where these creatures were no longer just dinosaur shadows, but active players in a cutthroat, high-stakes ecosystem. This drama played out quietly but intensely between roughly 201 and 145 million years ago. While dinosaurs owned the open plains and the sunlight, the world of Jurassic mammals expanded into every other corner, burrowing deep, scaling the trees, taking to the air, and even diving into the water. Fossils of these Jurassic mammalia forms reveal an incredible range of survival toolkits. You had natural-born excavators with stubby forelimbs, reinforced bones, and shoulder muscles thick enough to tunnel through loose soil, or the sediment along riverbanks. These tunnels offered more than just a hiding spot from teeth and claws. They were climate-controlled bunkers, keeping temperature and moisture stable, a huge plus when the Jurassic weather got wild. Shift your gaze up to the dense Jurassic forests, where giant pines and ferns blocked out the sky. Up there, tree-dwelling mammals feasted on a buffet of insects, eggs, and fresh fruit, safely out of reach of the predators stalking the forest floor. Some of these creatures took a literal leap. Fossils show skin membranes stretched between their limbs, just like modern flying squirrels. Now, this wasn't true powered flight like a bat, but it let them glide effortlessly from branch to branch, saving energy and massively expanding their turf. And then there were the ones who chose the path least expected, the water. Semi-aquatic forms evolved flat, paddle-like tails, webbed feet, and flexible spines, making them agile swimmers in the ancient lakes and swamplands. With bodies stretching over 40 centimeters and weighing in at nearly 800 grams, these were no fragile weaklings. Back in the Jurassic, mammals didn't try to go toe-to-toe with giant dinosaurs out on the ply. Open plains. Instead, they conquered the trees and the underground, expanding their reach up and out. The remarkable part? This explosion of diversity didn't just happen on one family tree. It erupted across several different lineages all at once. Fossil records show many of these early mammals developed highly specialized forelimbs, clearly adapted for specific ways of moving, whether for gripping, excavating, or gliding through the water. Their joints were flexible enough for a wide range of motion, yet their bones were built tough to handle the stress. That structural stability gave evolution the freedom to get really specific, allowing them to test drive new survival tactics without constantly getting wiped out by global disasters. Between roughly 175 and 145 million years ago, mammalian variety hit its absolute peak for the entire Mesozoic era. But right here is where things get tricky. With so many different groups thriving simultaneously, what happened when the heat turned up not just from the dinosaurs, but from rival mammals hiding in the same shadows? Picture the Mesozoic era, and you probably imagine titans battling it out, colossal dinosaurs fighting for dominance across sweeping landscapes. But alongside that epic saga, a quieter, hidden war was waging. A battle in the dark, where early mammals faced off against dinosaurs and navigated ecosystems that were already stacked against them long before they showed up. Now, these mammals rarely picked a fight with the big carnivores. Given the size difference, that would have been a suicide mission. Since dinosaurs owned the daylight and the open ground, they dictated the rules of the entire ecosystem, controlling everything from where food was found to when smaller creatures dared to move. The smart play for mammals was the night shift. We know this from their skeletal structures, large eye sockets, specialized optic nerves, and inner ear anatomy that suggests they had super sensitive hearing and vibration detection. While they didn't need eagle-eyed daytime vision, Owning the night let them dodge the big predators and feast on the insects and critters that scurried about, while the giants slept. But dinosaurs weren't the only ones trying to kill them. Pterosaurs dominated the skies, snatching up insects and fish. Down in the rivers and swamps, ancient crocodilians, with their semi-aquatic bodies, bone-crushing jaws, and lightning-fast reflexes were absolute nightmares to deal with. Even in places that felt safe, like deep burrows, thick forests, or murky swamps, mammals were constantly scrapping with each other as their populations exploded during the Jurassic. Survival came down to specialization, who could fit best into the tiniest ecological niche. Burrowers had to dig faster and deeper than their neighbors to stay safe. Climbers needed better grip and agility so they didn't get knocked off their perch or their lunch. And the swimmers? They had to master the water without losing their footing on land. These ancient mammals became masters of their specific trades. But hyper-specialization is a double-edged sword. It made them heavily reliant on stable environments. Forests had to stay thick, wetlands wet, and bugs plentiful. When the system worked, this hidden world was a well-oiled machine. But the threats weren't just environmental. The real danger was evolutionary pace. Mammals that played at loose omnivores with flexible strategies and adaptable movement styles tended to spread out and take over more territory without a hitch. Look at it through the lens of deep time, and you see a colossal experiment. Mammals were trying every trick in the book to survive in a landscape dominated by giants. Then, the Jurassic calm started to fracture as the Cretaceous era rolled in. Weather patterns turned erratic, and the plant life shifted. Nature started rewriting the rules, putting the squeeze on species that were too comfortable in the old ways. This mounting pressure signaled a disaster starting ages before that famous asteroid ever made impact. Throughout the Mesozoic, mammals were branching out into wildly different lineages. Dig into the fossil record, though, and you find that teeth are usually the only things left behind to tell the tale. Thousands of these enamel scraps allow us to reconstruct a much bigger narrative. A mammal's fate wasn't really about geography. It came down to dinner, specifically. Could you eat what was available when the menu changed? Take the multituberculates, the poster child for a dynasty that had a great run before crashing hard. Showing up 160 million years ago, they held on for nearly 130 million years. That is a track record few other lineages can match. Their molars were covered in rows of little bumps, perfect for grinding down hard seeds and rough fibers. But that specialized design was a dead end. Great for munching plants, sure, but terrible if you needed to pivot when survival became critical. Meanwhile, evolution was engineering a different breakthrough. The tribophenic molar, a 3-in-1 tool built to slice, puncture, and crush. You had blades for meat, spikes to pierce, and flat basins to grind. That design turned mammals into true omnivores, just as the world headed into a long streak of chaos, where dietary flexibility meant the difference between life and death. This blueprint launched the two heavyweights of the modern mammal world, marsupials and placentals. When the climate went haywire, the generalists were the ones left standing. This dental revolution teaches a harsh truth about natural history. Survival isn't about brute strength, it is about options. One versatile tooth unlocked the door to the future. As the Cretaceous pushed forward, the planet wasn't just getting different weather, the entire biological scaffolding was shifting. This set the stage for a planetary overhaul, a collaboration between flora, bugs, and beasts that would redefine Earth. About 125 million years back, a quiet takeover began. People think of the Cretaceous as just the dinosaurs' curtain call, but the real story was the rewiring of relationships between the plants and the animals. Flowering plants drove this shift. Early on, they were rare, barely 5% of the green cover. The old guard still ruled ferns, cycads, and ancient evergreens. By the time the curtain fell, that number hit 80%. Flowers had conquered the land. They bred faster and came in every shape imaginable. But their secret weapon was building complex alliances with the insects that pollinated. As blooms conquered every corner of the globe, the insect world went supernova in both scale and variety. A buzzing explosion of diversity, from beetles and bees to flies, offered a buffet, far more nutritious and reliable than anything nature had previously provided. Life on land stopped depending on tough scrub and sluggish metabolic rhythms, shifting instead to a high-octane web of life, teeming with complex layers and constant action. In this chaotic new arena, small, adaptable mammals found their moment to shine. The shifting climate of the Cretaceous played right into their hands as well. It was a greenhouse world, far hotter than today and lacking ice caps, where heavy rains soaked the tropics. Lush jungles marched across the landscape, burying the dry, simple scrublands of the past. While this dense greenery spelled doom for rigid specialists and open plain roamers, it was a paradise for the pint-sized, favoring nimble creatures that could vanish into the undergrowth and eat whatever they found. For the mammals of the Mesozoic, the tide was finally turning. The giants, locked into specific diets and clumsy frames, began to falter. Meanwhile, the little generalists, omnivores who could hunt or hide day and night, gained a solid foothold. The evolution of complex tribosphenic molars proved to be a game-changer in this era. These specialized teeth turned mammals into processing machines for bugs, fruit, seeds, and scavenged meat, allowing them to tap into the high-energy fuels scattered across this transformed world. Importantly, this wasn't an overnight coup that wiped out the old guard. Ancient lineages and water-loving oddities continued to thrive alongside the newcomers for eons. As for the dinosaurs, they were still the undisputed kings of the Cretaceous. Mammals didn't pick a fight. They simply mastered the shadows and expanded their niche quietly. The ecological shift was a slow burn, a long rehearsal for what was to come. It laid the groundwork for the most pivotal event in biological history. The KPG extinction acted as the ultimate grim reaper, finalizing the shift the Cretaceous had started. 66 million years ago, the planet slammed into the boundary that separates the age of reptiles from the age of mammals. In a heartbeat, a rock roughly 10 to 12 kilometers wide smashed into the Yucatan Peninsula, carving out the massive Chicxulub crater 180 kilometers across. The blast unleashed hell on Earth, hitting with the violence of billions of atomic weapons. But here is the crucial detail. The asteroid itself didn't instantly extinguish all life. Instead, it tipped the first domino in a cascading apocalypse that acted as a brutal survival test. Within hours of impact, the world descended into absolute madness. Shockwaves ripped through the crust while the sky rained liquid fire, sparking global conflagrations. The atmosphere choked on ash. Clouds of sulfur and dust blotted out the sun, plunging the globe into darkness. Temperatures skyrocketed before plummeting into a deep freeze, locking the planet in an impact winter. Without sunlight, the engines of photosynthesis stalled, yet extinction was not instantaneous for everyone. The fossil record reveals that plenty of mammals weathered the initial firestorm. They didn't vanish in the blast, nor did they fade away the moment the dinosaurs fell. The true killer of the Mesozoic wasn't the explosions, but the long, agonizing starvation that followed as ecosystems unraveled. When the plants withered, the food web collapsed from the bottom up, dooming the herbivores first. The apex predators, needing massive amounts of meat, starved into oblivion within a few generations. However, the scavengers, the tiny, low-energy omnivores, found a way to endure. The survival toolkit they had honed in the shadows of giants finally proved to be their salvation. Small mammals that made their homes in burrows along riverbanks, swamps, and semi-aquatic zones held a massive advantage. Temperatures underground were steady, and even in the dark, food was available: insects, carrion, roots, and buried seeds. Life found a way to persist in the shadows. But species that relied on a single food source or a specific habitat began to vanish. It didn't happen overnight, but faded away over hundreds of thousands, even millions of years, into the early Paleogene. That's the part people usually get wrong. The KPG boundary wasn't a clean line where everything instantly died or survived. The truth is, many mammal lineages from the Mesozoic actually made it past the impact. Multituberculates, for instance, hung on for tens of millions of years. We still find traces of these ancient forms in the fossil record of the early Paleogene. Yet, with every shift in climate, every change in vegetation, and every crack in the food web, the inflexible lineages were weeded out. The future belonged to the generalists' creatures with versatile teeth, varied diets, and rapid reproduction. They had been there all along, quietly sharpened by millions of years of competition in the dark. The asteroid didn't create them. It just revealed which survival strategy was superior. While the dinosaurs were gone forever, new branches of life sprouted as the old ones withered. The loss of those ancient mammals wasn't just an end. It was a brutal trial by fire, driven by a shifting planet. After living in the shadow of giants for eons, these survivors ran bold biological experiments, laying the foundation for modern ecosystems. Most didn't make it through that historic bottleneck, leaving nothing behind but fragmented bones encased in layers of decay. But that ruthless filter also cleared the stage. allowing for an explosion of diversity unlike anything before. The winners weren't necessarily the strongest, but the ones who could adapt to a broken, chaotic world. Their story proves an enduring law of nature. The fall of one dynasty plants the seeds for the next, eventually paving the way for us. Here, over here. The sheer scale of deep time is exposed in these striated cliffs. A record right here. Here. Look here. Everywhere. Here. Right here. Thanks for sticking with WUFO Space all the way to the end of this cosmic journey. If you enjoyed the ride and learned something new, hit that like button, share, and subscribe so you don't miss our next adventure. Your support means everything to us. It's what fuels our passion to keep exploring the great wonders out there.